Hi, my name's Damien, Application Engineer for Solitech. Today, the blog we're going to have a look at is creating a spiral staircase. This is a separate example I just thought I'd show you that can be used using the same technique. This one, however, uses a tapered helix to create a tapered spiral staircase. Okay, so starting with a new part, we're going to create our basic layout of what we want. We're going to pop on there a 2 meter wide staircase. I'm going to pop in the shaft at the same time, so we just dimension those up. So I made that far too big, and we'll make this one 300 mm. I'm going to draw in here my standard step size. So this is going to be my little drive-in sketch. We're going to use this to drive the whole model. That way we can reuse it and come back and do whatever we like later. So I like to do it this way. That way I always get a sketch at the top of my tree, and I carry on and include aspects of it that I want to use. So I'm going to include the step details. And then we're going to use the trim tool just to trim them off and make sure we end up with something we can extrude as a solid. So steps height is going to be 110 in this case. We're going to do it with a little solid. Just to go a little bit further, we can also use sheet metal. I'm going to convert this to a piece of sheet metal, so we can see we can also flatten that at the same time. That's an optional step. And what we're going to do now is, under the curves, you'll see we get a helix tool that allows me to convert any circle into a helix. So I'm going to create one sketch that includes just the outside circle. And this is what we're going to use to drive my helix. Okay, we have a number of choices of how we drive it. I'm going to do height and pitch. We're going to do We can do 4 meters, we can make it go high as we want. I'm going to say 4 meters with a pitch of 2 meters, which should be enough to walk up it. Okay, our start angle is, as we drew a horizontal line here, we're going to have ours at 270, but it could be start wherever you wanted. And you can choose the direction of your spiral as well. At this point you can also, this is where you choose to be a taper or not, so you could put a 30-degree taper on there. Oops. Maybe not quite 30 degrees, unless it was tapering outward. Okay, and we could do the same sort of thing this way, but we're going to turn off our taper and go like this. Okay, so the next aspect, I'm actually going to pattern this solid body all the way around that path. So we're going to use a curve-driven pattern. Lets me choose this helix or spiral as a path. I can choose how many instances do I want. Important thing to remember is to pattern the body. Okay, and I'm going to say I want them equally spaced around here, or you could do a pitch of a certain size. So the other thing we need to do is we can either have them aligned to the seed, as you can see they'll all be exactly horizontal, or we can align them to a face. So this has a tangential face to my pattern. Let me just click that once more. There we go. So that face there, so we can see we get the desired result. And all we need to do is just increase the number of items, so 29 is what I did last time, and we end up with a pattern. We can use this again to do further things. Next I'm going to create another body. We're going to include this item here and extrude this all the way to the top and a little bit further, so just choose your height. 100 looks perfect to me. Note that we have to uncheck merge result because we're not in the weldment environment yet. It needs to be a separate body because it's not going to be able to connect to these sheet metal components correctly. Next we're going to create the side panel. So I'm going to do this by making a new sketch. This time we're going to choose to use a 3D sketch and include my helix. The main advantage about this method is that we can now extend our helix. We can even dimension it. So I'm actually going to dimension it from a point to a point. Remembering I'm in 3D, hitting my tab key tabs between my 3 coordinate systems. How far do I need that over? I'm going to say 20 millimeters. And then we're going to use an extruded surface. Okay, and we need to choose a direction because we're doing an extrusion from a 3D sketch. It doesn't know a direction, so we need to choose an entity like a shaft to give me my direction, and then we just choose how far do I want to go. I'm going to overdo it one way, and then I'm going to choose direction 2, hopefully around about the same distance, and we get our little side plate. Okay, that looks perfect. Okay, before we turn that into a solid, we're just going to trim it. So I'm going to use my top plane to trim the bottom off, so we can see trim surface, and we're going to do the same on the top. I'm just going to add a plane on here to trim with, and trim surface with that plane, and we're going to remove this top piece. Okay, so very simple to move through there. We could make this a flattenable using a lofted bend. I'm just going to go straight for a simple thicken command, which is going to allow me to thicken this, and I'm going to choose quite a thick side piece because it's going to make it appear nicer. Notice that it won't want to merge results and it will have an error, so we're going to turn that off as well. There we go, so we're nearly done. All I need to do is put a handrail on, so we're going to do this in a similar fashion to how we've done the others. I'm going to create another 3D sketch with a line going straight up, and I'm going to lock that to Y, and we're going to connect this to my path. Notice how I haven't connected it anywhere in particular. I'm going to put it right on the end. I'm going to give it a height. 1 meter looks brilliant. And I'm going to use the structural member command. So I'm going to use a circular hollow section, or maybe what we'll use is a square hollow section 350 grade. 50 by 50. Okay. Then the key is we can locate by any point on here. So if we want to offset it a little bit further, all we have to do is draw some sketch points elsewhere to locate this and rotate it to where we want. But okay, I'm going to let you get into the details. Again, we can pattern this with a curve-driven pattern to get it all the way around. Curve-driven pattern, and the body we want to pan is this one, and the face normal. Slightly trickier because we've kind of hidden it with this thicken, but we can probably just use this inside face now. Choose how many do we want, equal spacing, or I want them spaced at 600. Don't need that many, but you can leave as many as you need on there. Okay. Then I would choose to actually create another 3D sketch, and we can copy it from this one here. I can probably just include the whole of that sketch. Using this sketch we can create another sweep and put the handrail on. and we're about done. So we're going to leave it like that. C1, I've just gone a little bit further in the time that we had, but doing exactly the same thing.